So our final example for our set notes, example 9, it says, let's say that you and your friends go out and get a large pizza. Let T represent the amount of toppings this restaurant offers. Letter A, if T is the set peppers and sausage, list all the different combinations of pizza that you could order. So I could order a pizza that just has peppers. I could order a pizza that just has sausage. I could order a pizza that has peppers and sausage together. And then I could also order a pizza that is plain, one that doesn't have any of the toppings. I could order a cheese pizza. So notice that all of the pizzas I have listed here are part of set T. So that means that if set T has 2 elements in it, notice we can get 4 pizzas from that. These 4 pizzas would represent part of the set, and remember, part of a set would be a subset. So we know that if we have 2 elements in the set, that's going to be equal to 4 pizzas or 4 subsets. So now let's look at part B. So part B, we're changing the toppings that we have available for our pizza. So now our toppings include pepperoni, sausage, and bacon. And again, they want us to list all the different combinations of pizzas that we could order. So again, I'm going to list all the ways we could order one topping, which would be pepperoni alone, sausage alone, or bacon alone. Now I'm going to list all the combinations with 2 toppings on it. So I'm going to do pepperoni with sausage, pepperoni with bacon. So I did pepperoni with each one. And now I'm going to do sausage with bacon. Notice sausage and pepperoni is already here. Okay. And then bacon and pepperoni is already there also. So my next possibility would be to order a pizza with all 3. So pepperoni, sausage, and bacon. And then my last choice would be to order a pizza that contains just cheese. So again, not using any of the elements. So again, set T has 3 elements. And notice we can make 8 pizzas, or there's 8 subsets to this particular set T. So 3 elements gives us 8 pizzas or 8 subsets. So let's look at the last one. So the last one, set T, has the toppings, onion, sausage, mushrooms, and peppers. And again, they want us to list all the different combinations of pizzas we could order. So we're going to first list all of the ways we could order one topping, which would be onions alone, sausage alone, mushrooms alone, pepper alone. Now I'm going to list all the ways we can order a pizza with 2 toppings, which would be onion and sausage, onion and mushrooms, onions and peppers. So I did onions with each one. So now I'm going to do sausage with each one. So sausage and mushroom, sausage and peppers. Notice sausage and onions are already here. Now I'm going to do mushrooms with each one. So mushrooms and peppers. Notice mushroom and sausage is here. Mushroom and onions is already here. Mushroom and sausage is already here too. Okay. So, and I already have peppers with each one. So now I'm going to list my combinations of 3. So I could do onion, sausage, mushroom, the first 3. I could do onion, sausage, peppers, the first 2 and the last one. I could do sausage, mushroom, and peppers, these 3 together. And I think that's all of them. And then remember, we could still order a cheese. Oh, and I forgot the one with all 4. Onion, sausage, mushroom, and peppers. So if we count, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm missing one. I think I'm missing one of the combinations of 3. So let's see, we have onion, sausage, mushroom. We have onion, mushroom, peppers. Onion, mushroom, peppers is the one I'm missing. So onion, mushroom, peppers was what I was missing, because we should have 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So if we have 4 elements we can get 16 pizzas or 16 subsets. Now, notice the very last question here is asking us, can you generalize this pattern for the number of subsets possible? So notice something that we found out. Notice that all of the number of pizzas, or the number of subsets, I should say, notice are all multiples of 2. Here I'm multiplying 2 2's, and 2 is the number of elements in my set. Here I'm multiplying 3 2's to get 8. 3 is the number of elements in my set. Here I'm multiplying 4 2's to get 16, and notice 4 is the number of elements in my set. So here, 2 to the power of 2 gives me 4 subsets. Here, 2 to the power of 3 gives me 8 subsets. Here, 2 to the power of 4 gives me 16 subsets. Notice the power for each one. The power for each one is the number of elements in that set. So we can generalize and say the number of subsets for any given set would be 2 to the power of however many elements are in that set. So the number of subsets possible, so the number of subsets possible is 2 to the power of the number of elements in the set. So we can say it's 2 to the power e. Let me fix that, e. 2 to the power of e would represent the number of subsets possible. Represents the number of subsets possible.